Welcome to the review of the questions on the Emerson workshop test. So this is the no calculator section. Let's go ahead and begin. In number one, this is given to us as a linear model. So we know then that this is a line. And basically it's an mx plus b form. All right, so that means that what they're telling us here, n equals 56 minus 2y. That represents a situation where the n is replacing the y value, the y is replacing what we normally expect to be the x value, the m is -2, and then the y-intercept is 56. All right, so let me label that down here. When we look at linear models, we don't usually need to look at the negative values for x and y. So in this case here, what we have is a situation where on the horizontal axis, again, it's the y value because that's replacing what we normally expect where the x is. And then the n is replacing what we expect the y to be. The y-intercept, that represents the starting value. It's also known as the initial value. So we're starting at 56. In this case here, the slope, it's -2. Lines with negative slopes go down, right? So when we have a negative slope, that shows us that there's a decreasing rate of change. So we can immediately then cross off A, because remember again, we're looking for something that is not true. And this is absolutely true. The initial value, or the starting value, the y-intercept is 56. The negative slope is also letting us know that it's decreasing, right? So we can also immediately cross off B. In C, we're looking for some information. Now, here we have to do a little bit of calculation, a little bit of interpretation. If we look at what this is describing, this model represents Y years after 2005. So that means that at this point, if we're talking about the year 2015, the Y value would then be 10 years later. And if we plug in a Y value of 10, and remember, in our equation, it's 56 minus 2y. If we plug in that 10, we're going to get 36. And again, we're looking for something that's not true, so we can cross that off as well. We're just left with D, so that must be the right answer. But let's look at specifically why that answer is wrong. So the average number of students from 2005 to 2015 was 48 students. Well, we just found the number of students in 2015, right? Our calculation was just completed. So we know that there's 36 students in 2015. And how many students were there in 2005? Well, that represents where the model begins, right? So that's literally the starting value or the initial value, and that was 56. And guess what? When you average 56 and 36, so add them together and divide by 2, we're going to get an average value of 46. And that value is slightly off because it says it's supposed to be 48. Let's look at number 2 next. So number 2, this is a straight up proportion. We can distribute the left-hand side and make that 3k plus 6. Now we can just kind of cross multiply if we would like to. Me personally, I'm going to just show you how to clear fractions. I like to clear fractions. So we could think of it like a clearing fractions as multiplying by the number that would have been the common denominator, right? So if we were trying to get the common denominator, it would have been over 4. But if we multiply by 4, what's going to happen is it creates a situation where we can avoid a little bit of the bigger numbers that might show up when we just straight up cross multiply. All right. Now, there's nothing wrong with cross multiplying. I'm just showing you a slightly alternative approach. And then from here, this is obviously just a matter of just like finishing off some simple algebra. So the answer is A, -10/3. If you had decided to cross multiply, let me just show that. It would have been 4 times 3k plus 6 equals 2 times 3k plus 2. And again, you have things are manageable. The numbers are a little bit bigger, but this would have also given us the same exact answer of 10 over negative 10 over 3. Okay, let's look at number 3 next. So in this one over here, I'm noticing right away there's a keyword kind of embedded in the middle of that problem there. We want um, another line. We'll figure out some information about the other line, and it's perpendicular. Okay, so we're trying to find information about that other line that's perpendicular. So guess what? Our first step should be to figure out what that slope is going to be. All right, so if the slope of the first line is 1/3, then the slope of the perpendicular line, and that little upside down capital T is what we use to represent perpendicular, that would be -3. All right, change the sign, negative or opposite, and then reciprocal, flip it. So 1/3 becomes 3/1. Okay, so we've got the slope now, right? We know it is -3. So how can we finish off the work? Well, we want to find the y-intercept, which conveniently is the b value. Where can we get an x and a y to therefore get a numerical value for b? Oh, lucky for us. Every time we get a coordinate on the SAT, it represents an x and y value that might be helpful, right, for plugging in. So here we go. We're going to plug that in. X equals 3, y equals -2. So let's do the math there. -2 is going to be equal to -3 times 3, so that's -9 plus b. And the end result is going to be that the b is equal to +7. And that's all they're asking for, so there we go. Now, if they asked us for the equation of the perpendicular line, of course, we would just rewrite it with the m and that b and leave the x and the y as variables. So y equals -3x plus 7 would have been the equation of the perpendicular line. Okay, let's do number 4 now. So for number 4, this is again another proportion. So we can cross multiply. All right, so let's multiply x times x, that's x squared. 3 times 3 is 9. If we solve this using the square root property, then x is equal to ±3. And we are trying to figure out the value of 1/x, where x is a positive integer, right? So that's one of our conditions. So we're going to take the +3 and put it underneath a 1, and that means that the answer is C. Just in case you want to see it the other way, to solve a quadratic equation like this, we can move everything to the same side so that we get an equals 0. And then from here, we can basically factor this, and we would have gotten the same result, that x equals -3 or x equals +3. Okay, so you can either solve it using the square root property or solve it like it was a quadratic by moving everything to the same side and factoring from there. On to number 5. This is another proportion. Oh my goodness, lots of proportions on this test. So if we cross multiply in this one, we get 16x equals 4y squared. Okay, now this is where we're looking again for something that is not equivalent. So reading certainly is important here. All right, make sure you always read carefully. On the real SAT, they don't really emphasize like which one is not true or which was not equivalent, but this IES workshop test certainly does. So from here, I'm just looking at this and kind of going, okay, we are looking for different ways of getting this. So if I divide by 4, that'll help us figure out, is that first answer correct? And the first answer is equivalent. So we're looking for something that's not equivalent. We can cross that off. Second one, we're looking for, okay, x by itself. All right, we can do that. If we divide by 4 on both sides, oh, this is problematic. X is equal to y squared over 4, and that's saying x is equal to 4 times x squared, y squared. So that one is our correct answer. We don't have to go any further than that. Okay. On to number 6. Oh, right. So one of the things that is super important on the SAT is to remember that f of x is equal to y. In some cases, it means that you just need to remember that if they give you a function, you can replace the f of x with y. All right, so that's one usage of that knowledge there. But the more important knowledge is that you have to understand that if I give you like f of 2 equals 3, for example, then that means that we're talking about x equals 2 and y equals 3, and we can even put that as a coordinate, 2 comma 3. All right, so it's just simply like kind of knowing what we're getting when when we're given a function statement like this. So this f of 5 equals 0 is basically telling us that x equals 5 and y equals 0, or in other words, this is a 0 of the function that we're seeing, all right? Because this 5 comma 0 is a point on the x-axis. It's on the x-axis. Therefore, this is an x-intercept. And when we have x-intercepts, they're the same as things that we call roots, zeros, or solutions. Okay, so whatever this polynomial function looks like, those x-intercepts are the roots, zeros, or solutions. And how do we get to a solution? We factor things, right? Like I'm just going to pop in kind of like a representative sample of something that might kind of be factored from a polynomial. And then we get our solutions as the values that are kind of like the opposite sign, right? So the factor of x minus 1 tells us that there's an x-intercept or a solution at x equals positive 1. X plus 2 tells us there's a solution or x-intercept at x equals negative 2. So that tells us here that, hey, if we want to get x equals 5 as a 0 or a solution, that means that one of the factors must have been x minus 5. All right, so that sign changes is important, right? Remember, when you factor it and you get x minus 1, we don't say the value of x is x equals negative 1, right? It's x minus 1 equals 0. And then our x is, again, the opposite sign. Okay, let's look at number 7. So for number 7, this one is one of those answer choices where if we look at the answer key, we can pick up a valuable hint if we don't know what's going on. There's only x's, right, in the 4 answer choices there. So basically that lets me know that, oh, this is a substitution problem, all right? Instead of y, I'm going to replace it with what y is equal to, which is x cubed plus 2x squared plus 1. And then when it says minus xz or minus x times z, that means that I'm going to replace what z is equal to and then multiply that by the x, right? Because again, it's minus x times z. So now we just need to simplify, or actually distribute, I guess is a better way to phrase it, that second part, and then just combine like terms with what we have in the front. So x cubed minus x cubed, oh, there's no more x cubes. So C and D go out the window. And we have 2x squared plus x squared. So that's going to be 3x squared minus, oh, sorry, plus 1. And that means the answer is B. All right, so the next one on this page, the last one on this page, is number 8. So we always just want to remember, if there's a complex number in the denominator of a fraction, that's always something that we have to deal with, okay? So no matter what it says, just deal with it. And how do we deal with a complex number in the bottom if it's no good? We have to multiply by what's known as the complex conjugate, right? It's a fancy name, but all it means is just we change the sign. So if we have 2 plus I on the bottom, we're going to multiply by 2 minus I. And here's the thing, if we just multiply the bottom of the fraction by 2 minus I, that's going to affect the value of the fraction. So we're going to do something kind of ingenious. We're going to multiply the top of the fraction by 2 minus I as well, right? Because what happens when we multiply by 2 minus I over 2 minus I, we're really just multiplying by 1, right? Anytime the top of the fraction and the bottom fraction are identical, it just simplifies to 1. So we're going to change its appearance, but we're not going to affect the value of the fraction by multiplying by 2 minus I over 2 minus I. So in essence, we're going to have to do a little bit of foiling on, in this case here, on both the top and the bottom. Let's deal with the bottom first. So when we do the FOIL, right, 2 plus I times 2 minus I, it's going to be just like if we had 2 plus x times 2 minus x. We have to do first, outer, inner, last. We have to do first, outer, inner, last. So the first terms would be 2 times 2. That'd be positive 4. The outer terms would be minus 2i when we multiply it together. The inner terms would give us positive 2i. And that's what we want. We want to get rid of the i's. So notice that cancels out. And then you might think we still have i's left over, right? And we do. It's going to be plus I times minus I, so it's going to be minus I squared. But here's the thing. On the bottom of a fraction, if we have I squared, we have to know that if I is equal to the square root of negative 1, I squared is equal to negative 1. Okay, it's the square root of negative 1 times the square root of negative 1 is equal to negative 1. So when we replace that with negative 1, it turns into 4 minus negative 1, right? 4 minus negative 1, because remember, there's a minus sign out in front. So 4 minus negative 1 is 4 plus 1, or 5 on the bottom. And then on top, we have to do some foiling as well. So again, 2 times 2 is 4. This time, the I terms from the outer and the inner are not going to cancel out because it's minus 2i minus 2i. And then the last terms is going to be plus I squared. And again, if we see I squared, we have to replace it with negative 1. So this will be 3 minus 4i over 5. And that means that the final answer is B.